I've arrived.
Athena.
Yes.
Athena 6, right?
Yes. That's a rocket right there. Yep. Wait, the trees are blocking it. That's rocket. We're on NASA.
Fucking rocket right there.
NASA Parkway right now. That's a rocket. Here's our ride. Thanks, NASA.
Billion ping pong balls inside that building.
250 billion ping pong balls can fit inside this building. How crazy is that?
The next question is, yes, you're right.
Wonderful.
Somebody at NASA had way too much time on their hands. They travel less than a mile an hour. And for every 32 feet, they burn a gallon of fuel. And that is a hybrid. It was built in the 60s, an alligator. They do get up on
Launch pad 39B. Currently now considered a clean
See how this
pad.
fence is curved outwards? Anybody take a guess why?
To widen it to the actual rocket booster. And then, so that 541, 5 is for 5 meter diameter, 4 is for 4 solid rocket boosters. And they're strapped on, actually this is 5 solid rocket, but the one we have out on the pad, or is going to the pad today, is 4. Each one of those weighs 100,000 pounds. And it's solid fuel, a lot of thrust. That rocket leaps off the pad with these SRBs. So the one, okay, that's.
So if you guys could actually see the lightning rods that are out far in the distance, actually it's like right behind me. Those are actually to detect lightning, so that's actually safety when you're gonna have a launch. So before the rocket takes off, that's gonna be carrying the weather satellite, you actually want to have these 4 rods which will be detecting lightning. There's actually a really thick wire that holds each of them together with a massive hole in the center, and that hole in the center actually allows for the rocket to go shooting through it. But once it shoots through it, then it's strong enough. It actually can withstand the really strong vibrations that come from the rocket. Actually, about 18 seconds before the rocket is launched, there's about 300,000 gallons of water that is released to actually absorb the sound waves from the rocket when it's starting to launch. And this is actually to help protect anything nearby. It can actually shatter windows up to 18 miles. Word.
Umbilical tower. Now come 2018 is when they're gonna begin their unmanned test flights. 2023, looking at the moon and an asteroid. And come somewhere around 2030, they have their eyes on Mars.
Yeah, that's ambitious, right? That's like
In the Apollo program.
Mobile launcher.
And that particular platform right there launched Apollo 13
Apollo 13.
with astronaut Tom Hanks.
Wow. Back at the vehicle assembly building. NASA and palm trees, my way of living. Finally made it. Vehicle assembly building. Look, Ma, I made it to NASA.
Mars getting closer to our paradise.
Oh yeah. And they're doing it, and they're like, hey, come here, look at this. And they were showing us.
Hey guys, so I didn't actually have service to be able to do a Facebook Live because I am on the roof and it's like insane. It's beautiful. This is the view. 526 feet up.
Each show we hire
She actually did she actually did a black and white still.
There's this guy,
Right now. One of them that I like a lot that relates to what we're doing today or tomorrow is Minx. It's a Colorado-built small spacecraft that looks at X-ray output of the sun, and it does so with high temporal resolution. So it's a tiny little thing that was thrown out just the door, just like the one that you're talking about. And you know, it's taking measurement. It's going down slowly, and it will burn up eventually because the atmosphere will get it. You know, and so now in the meantime, it's doing these measurements that we used to do just on big spacecraft. So it's a really cool small spacecraft. There's others. I could go on and on. So yes, there's a number of them, and in a number of areas.
One of my followers had a question about launching closer to nearer to the equator as opposed to other areas on the planet. What are the mathematical benefits of doing that?
So the benefit of that, of course, is you remember how this goes. It's kind of all about energy, right? It takes so and so much energy to get to orbit. So the question is, with what energy are you starting? So
Yes.
if the Earth didn't rotate, it wouldn't matter which way you go because it's away from the mass center. But what happens if you're at the equator, you get kind of the maximum amount of the rotation with you,
Yeah.
right? So basically what you do is you go close to the equator and kind of go, take that velocity, and so you need less velocity to add. Of course, there's some velocity you lose because of friction, so it's not that easy. But yes, that's the benefit. So you get more velocity from the Earth's rotation, kind of around the equator. So if you were launching from the pole, which we've never done, you don't benefit at all.
Crazy.
Standing like a rock, right? It's just twisting. Yeah.
Great, thank you.
Yeah.
Thanks.
Follow me, Dr._Thomas C. I'm starting out right now. I'm gonna spend a lot of effort on it. I also want to profile some of the cool people that work there. So, for example, if you looked at this right now, I was in a lab where I met this scientist, and she's growing veggies for space. So she actually has growing vegetables on the space station, and she's actually doing them, also growing them here right now. So it's the real kind of Martian. So Dr._Thomas C, right? Reach out. Also, if you're in DC, come swing by. I mean, I really am passionate about what you're doing. And so thanks again. I'll see you later. Wonderful launch. Let's have a wonderful launch, okay? Thanks so much.
Thank you.
Gantry, is this still in use, or is it just...
No, we've actually taken that as service. This facility was first built by the Air Force.
Delta
assembling,
Tube.
Missiles, or ground missiles. We're going to explain some of it. This is a working operational facility. We're going to take you into the Mission Director Center. This will be used tomorrow for the launch. So the only thing I ask is don't hit the buttons and talk on the lines because they're actually trying to do RP1 tanking still there and then get upset with us. But we're going to
It's the countdown. Good morning from me and my astronaut friend right here. So today's adventures are going to consist of a few different things. One of them is actually a Mars simulator. Another one is going to be the science of a sphere given by NOAA. And I'm going to be meeting with the astronaut of the day. So if you guys have any questions for an astronaut, let me know and I will ask them. And followed by the finale, which is the launch of the Atlas V and the GOES-R satellite. That's going to be at 5:52 p.m. tonight. So stay tuned, guys. Say goodbye. Just got to the visitor center. There's a giant astronaut. He's holding that rocket in place. No, he's not. The rocket's actually very far away.
Faster, 3 times more data, more spectra to see all these wonderful. Because when you're a human going around the Earth, you can't see this. You just see the visible light. So we had to change our body clocks to match theirs. So we were actually 12 hours off. So I launched at about 5 in the morning. It was really 5 at night to me. And then so we launched and went to bed. But I would always stay up after going to bed because at 10 in the morning, which is 10 at night for us, I would fly by my hometown. And so I would take pictures of Scranton, Pennsylvania, in my hometown, and from the cockpit window, looking out. So that was sort of my feature. I tried to get it, and it's pretty neat when you're taking pictures. Like you're looking at it, and it's like this. It's not like a map with the lines and the highways and everything. And so Pennsylvania kind of looked like you can see that the ice had come down and really formed the Great Lakes and even the Finger Lakes. So if you look at the second Finger Lake, it's kind of bent, and when you look at it, it points to the Jersey Shore, and you back up about an inch, and then there's a white crescent, and that's Scranton, Wilkes-Barre. And so I would have to find it. We would fly over, and you're flying 5 miles a second. So I would actually, be looking and see that, and then I would go on it, and then go back and see the crescent, and then I'd take pictures of it, as we were either an ascending or a descending node going around the Earth. So that was pretty cool. That was my favorite portion because I knew people down there. Put from the medical kit a bone saw, and that grounded me to so I taped that around my hand and used that to ground so I didn't put any electrostatic shock in it. And then actually I wired it, and we kind of duct tape over some wires, and we actually got it running. So if we had a 3D printer, we could kind of make some stuff but it's still fun being the guy. But I think there's a lot of potential with 3D printing both here on the Earth to build complex things like this.
GOES-R will also carry an instrument known as the Geostationary Lightning Mapper. This important instrument will allow the satellite to detect continuous lightning flashes, another technological breakthrough that will give forecasters extra lead time on impending severe weather. Not only will GOES-R include weather observations, but the satellite's advanced instruments will measure a vast range of environmental conditions that, when merged with other satellite products, will provide a more complete understanding of our dynamic planet. Of course, GOES-R will monitor more than just the Earth's weather. The satellite is a suite of instruments that play a critical role in monitoring space weather by tracking solar flares and eruptions that, if strong enough, could disrupt the communications infrastructure on which we all depend. From the surface of the sun to the weather on Earth, the advanced technology flying on NOAA's GOES-R satellite will take weather forecasting to new heights.
A week-long coast time, I believe, which will enable us to do some really cool things like something we call distributed lift, where the ACES stage could stay up in orbit, and like for example, you could launch basically a gas tank up to orbit, right? And then you could launch another mission that now needs to be refueled to go to Mars or to go somewhere further. It can refuel then in orbit and continue on its mission. So right now, our Centaur isn't capable of having super long burn. I mean, we burn for 8 hours sometimes on missions, but it can't stay up there for a week. It doesn't have that capability, and ACES will enable that. So that kind of opens up a whole new realm in space with being able to refuel or just have something that can be up in space that long that you can then go use again, basically. Like she said, it could be reusable, so potentially you could just put one up there and then go refuel it whenever you want it and use it again for something else. So it's kind of a cool capability that this next generation of rocket is going to have, basically. The ACES, well, part of it has the potential to be reusable. The booster itself will not be, but we have been looking at something that we call smart reuse, and we have some YouTube videos on that if you want to see the whole thing. It's pretty cool. But the idea behind that is that the engine is the most expensive part of the rocket and the most complex part of the rocket, so we want to reuse the engine portion of it, because the booster itself is, not to make it sound bad, because the booster is what I work on, so I love it, but I mean, it's pieces of metal welded together, it's literally just a tank. So it's really not that expensive to make a booster, but the engine is very expensive, so we want to retrieve that engine potentially in the future and reuse an engine as opposed to reusing the whole rocket.
Behind you. That's just amazing, right?
So where are all you folks from?
All over. South Florida.
New York.
New York.
New York, yeah.
I like your pants.
Thank you. Thank you. I actually do have a question for you. One of my followers was wondering, what is it like to sneeze in zero gravity? Did you actually ever sneeze? Yeah, they were wondering that. I don't know if you encountered.
I don't know if I remember or not. But it'll be goofy if you do.
Yeah.
You probably, if you weren't fastened to the floor, you'd probably just pitch over backwards. Not very fast.
Yeah.
Yeah.
That's great. Thank you.
Yeah.
That's really cool.
Did you sneak
awesome.
anything on board with you?
Yeah, I sneaked on a wristwatch.
Okay.
It was one of those, do you remember what they used to call a self-winding watch?
Okay.
It had a little counterweight inside of it, and as you move your arm, it would wind your watch. Well, I wanted to know if it would work in weightlessness.
So you conducted your own experiment?
Yeah. So I wore it on my ankle. And it worked.
It did.
Yeah, it worked beautifully.
That's awesome. When you came back down, what did you experience? What did you have to, after 84 days?
Well, we had exercised every day, and we were in really good shape. The crews before us hadn't exercised as much, and they were having trouble. So NASA said to us, you guys go ahead and take an hour and a half every day, which we did. The people up on the space station are doing it for 2.5 hours a day. And you've had guys stay up there for a year and come back in reasonably good shape.
Did you experience any vision issues?
No, not particularly. I noticed that I needed more reading glasses more, because the pressure in the eyeball changed a little bit. The shape of the eyeball changes, so the lens changes.
Oh wow!
Wow.
Yeah, and that even like they say you can get a sore throat and get sinus congestion because everything stays up here in space, right? You experience
right.
Yeah.
How did it feel looking down at Earth?
I felt like a big slob. All of a sudden, I was no longer a butterfly, and I had this big watermelon up here, and every time I shook it, it threw me off balance. So I learned not to say yes or no. I just say yes and not move my head, because if I went like this, it would.
Oh.
And that lasted for about 3 days.
Did it change?
Go ahead. No, you go ahead.
Did it change like your perspective of life being up there?
Oh yeah. 95% of the guys who come down from space all have this whole new idea of perception of Earth. And Earth is just a little tiny marble out in the vastness of space. And as we were going around, you could see on the horizon, you could see this little blue fuzz. And that's the Earth's atmosphere. Outside that fuzz, it's nothing. And if the Earth was an apple, the atmosphere would be about as thick as an apple skin. Wow. So it really demonstrates graphically to you that we need to take care of this Earth of ours.
Was there a particular mission that you were sent to perform, or the purpose of the time you were in space?
We had 3 major tasks. One was to study our bodies and to see what it takes to stay in space for a long time. And from what we learned is why the astronauts and the cosmonauts are being able to stay up in the station for over a year. We had 2 other main tasks, and one was to study the sun from outside the Earth's atmosphere and gather a lot of solar data. And the third task was to look down at the Earth and do a lot of photography in various places on the Earth for people who were studying various things like meteorology and desert formation and St. Lawrence Seaway freezing over and fault zones.
We were busy.
Yeah, we were busy.
Is there any training that goes into the possibility of experiencing extraterrestrial life, even if it's just like bacterium or like a micro? Is there any type of training that goes into
No, there wasn't
that?
any specific training at all.
Okay.
We did we took a lot of biology samples of ourselves up there, and the whole inside of the spacecraft. We would take little samples now and then and put them in a vial to bring home, because we found that the first crew had left microbes and germs and things that we picked up, and we found them on us when we got back down to the ground, but they were unique to the first crew.
Wow. Do you think there's any like possibility of soon encountering some type of life, maybe on another exoplanet? Like, one of my followers was wondering
I'd say
about
it's
that.
very, very faint because
Very
the distances are too big,
Yeah.
too large. It would take more than a person's lifetime to get to some other place where there might be another person.
Thank you.
As Carl Sagan would say, it's billions and billions and billions of miles away.
Carl
If
Sagan's
you had
great.
the opportunity to go to Mars, knowing that that's being
That's
planned.
the follow-on,
Yeah.
That'd be a great,
Be a pretty cool trip.
great challenge. The guys going to Mars are in middle school right now.
AstroKate became the first person to sequence DNA in space, and so I'm wondering how you think that will affect the future of space operations.
Oh, that'd be interesting. I don't know.
We just did the launch experience. Is that anywhere near close what it actually feels like?
Oh yeah, I have. See, what I flew on is out there lying on its side. That was the S-1B.
Okay.
That was the last of the old liquid rocket launchers. But the guys who have flown the shuttle say that shuttle experience is very, very close to being the actual experience. So don't hesitate to try it.
Did your chance to see the Earth from orbit to orbit Earth 16 times every day? Did that change your sense of who we are and global politics, and because they change and they get crazy and all sorts of stuff happened, and meanwhile you're just going around and around. How did that?
When I was airborne, the Watergate thing was going on, and the people on the ground didn't want to tell us about it because they were afraid we'd make some unnecessary remark. Ed and Bill, the two guys that flew with me, they both are quoted as saying that the fact that from space you can't see any of the boundaries that we set between ourselves is really, it was very, very striking to them. The only boundaries that are rivers are the only ones you can see. All the rest you can't see.
Wow. It all disappears at 250 miles up.
The word is we're all in the same boat.
Right.
We got to learn to live together and not be fouling up our earth and destroying each other. Because wars are one of the worst polluters in the world.
Yeah.
And we just have no business fighting wars.
How old were you when you fell in love with the sciences?
How old were you?
Yeah.
Well, I was in love with engineering and flying. I wanted to be a pilot. So when I got out of college in the Naval ROTC, I went Marine and I became a Marine fighter pilot. And I flew fighter planes for about 11 years until NASA picked me up.
Wow.
And then I got to fly something higher and faster.
Yeah. That's amazing.
Is that how most of the early astronauts came from a fighter program?
Well, most of them in the early days came from the test pilot programs. And they didn't start taking just fighter pilots until my group. My group was the first one to induct people who didn't have the test pilot training.
So there's a group of people I'm trying to sway into believing that the Earth is a sphere. Do you guys know about the flat
Yes.
Earth? And you say once and for all, the Earth is a sphere.
The Earth is indeed a sphere.
That's awesome.
That's a good one.
You're on record. You're on record now.
Did you experience any solar activity, any solar storms?
Oh yeah.
You did.
Ed Gibson, who was our solar physicist on our flight, he is the first person in the world to capture a solar flare from the very beginning until the end of it. And he captured it all we had a whole array of different kinds of sensors looking at the sun. And it's been unpredictable when it was going to happen, but Ed just had a hunch. And he threw all the switches on and then it happened. And then he shut them all down after it was over. And he used up about 30% of all of our data capacity when he did that.
Did you see
So he was
auroras up
gutsy.
there? Did you see any auroras up there?
Pardon?
Auroras or northern
Yeah, like
lights?
Oh, auroras are beautiful.
Yeah?
They look, from above looking down, they look like a picket fence.
Ah.
You know, they all have things going up this way. Actually, you say they're going down this way, but they're all connected at the top.
Was it green?
Yeah, green and a little bit of pink and lavender.
Would you go on a one-way ticket to Mars?
I would.
Would I?
Would you go on a 1-week ticket to
No,
Mars?
that's dumb. That's like asking a woman if she'd be willing to conceive a baby and carry it in space. Another dumb idea till we know more.
A lot of people signed up for that, apparently.
Yeah. During your 84 days, was there your 84 days in space? Was there a day that you might have thought like oh, things aren't going right today, or where something made you nervous about?
No, nothing made us nervous. All of our stuff worked. Everything worked well. Some of our experiments didn't work right. We had to repair them and get them running again. We had a gyro failure that caused us to curtail our activities and quit doing certain things, but we were running on 2 stabilizer gyros instead of 3. But that's about it.
What's re-entry like, and then landing? Like, where did you land?
We landed about 200 miles west of San Diego in the Pacific. And re-entry, you're going in backwards, on your back on the couch. And the windows are right here, so you see this flame coming around the windows. And we called that the rosy glow. And when the first chute comes out, it's just a little drogue chute. And it kind of stabilizes everything and gets you stabilized. And then at about 12,000 feet, the 3 big chutes come out. And then you're descending at 15 feet per second. And you hit the water with a splat, but it's not something that rattles the cage.
Okay. How quickly does the Navy show up?
Well, we landed right next to the carrier. In fact, we like to say that the carrier had to move because we were going to land on it.
Where's your command module now?
It's in the Air and Space Museum. It's in the door of the Apollo room, hanging from the ceiling.
The Chantilly or DC one?
Pardon?
The Chantilly or the DC one?
Which location for the Air and Space Museum?
Oh, the Air and Space Museum in D.C.
Is there a noticeable temperature difference as you came through the atmosphere and you saw the rosy glow, the flame? Is there a noticeable temperature difference? Was it warming up?
Not much. Remarkably, it was well insulated, and so we didn't feel much of it. And that we didn't hear any sizzle when we landed in the water. I'm sure
That's
there
good.
was. But when we hit, we were swinging from the chute like this. When we hit, we were over here, so we sliced into the water, flipped over upside down. So we were looking out the windows toward the bottom of the ocean. And we had to inflate our stabilizer bags in the front end of the spacecraft. And when they inflated up, it flipped us over on our back, so the frogman could come down and fasten the stabilizers around us.
After all that time, that must have been quite a ride coming back and getting all those G's on the way down and
it wasn't too bad. It was only about 2.5 G's.
Okay.
So you can get more G's pulling a loop in a fighter plane. That's a 4G effort there.
Thank you so much for
you're welcome.
Yes, thank you.
That was awesome.
Thank you so much.
Thank you. Take care.
Thank you guys.
Thank you.
So.
And thank you guys for watching. Peace out. See you at the launch. So now you can actually hear the announcements being made, which is going to be happening live while the launch is actually taking place. Right now, this is my view. Right across the water is where we will be able to watch it live as the rocket actually launches. I mean, guys, this is huge. This rocket is amazing. It's massive. It's going to be telling us at which stages, which engines will be going at full thrust. It's going to be insane. It's going to be about 900,000 pounds of thrust in the RD-180 rocket engines. It's going to be crazy. And so once again, this is the Atlas V, and this is Astronaut here covering it for you guys.
On Cape Canaveral Air Force Station in Florida, watching a live view of the Atlas V rocket with its Rose-R NOAA satellite payload, poised for liftoff at 5:42 p.m. Eastern Time. Crowds have gathered to watch the launch. News media, meteorologists from around the country are here. Everything is go. Weather is 100% go. As we last checked, we're about 30 seconds away from receiving another weather briefing from 45th Weather Squadron forecasted flight.
Okay, now we're at about 12 minutes until the launch. I'm so excited.
Just a couple of seconds away from entering our built-in hold at T-minus 4 minutes. T-minus 4 minutes in holding. This is a program 6-minute hold.
2 minutes, 4 minutes.
As you heard the teams issue, we will not be launching at the beginning of the launch window. We'll stand by for further information. And as you got these teams have been advised to hold off transferring the GOES-R spacecraft to internal power. We must launch by 6:42 p.m.
We must launch by 6:42 p.m. We only have a 1 hour launch window, and there actually is about a 10-minute hold that they actually just announced. So they're just working on a technical issue right now, and yeah, and we will see what happens soon.
We remain in our T-minus 4 minute hold, awaiting resolution of the launch vehicle issue.
Launch vehicle issue.
So the Amplified rocket with the GOES-R spacecraft will not be launching as expected at 5:42 p.m. issue that continues to persist. And the new possible...
There's a launch vehicle issue. We're still holding the T-minus 4. New estimated time.
That would leave us with 35 minutes remaining in the hold.
35 minutes remaining in the hold. That is a long time. That's where we're getting very close to.
Provide information as it's available. Once again, though, we are at T-minus 4 minutes and holding.
Yep.
This is Atlas Launch Control.
Okay, so as you just heard, they're now resolving the issue. So the hold is going to be still for about another extra 10 minutes. So the launches maybe still be about 6:02 p.m. And yeah. Okay, so now it's going to be delayed by about 30 minutes. So yeah. And this is what it looks like from across the lake, from the launch pad. We're all waiting. In the meantime, here's a beautiful view of Venus. Yeah! Can't really see it too well with this super bright light right here, but there we go. Say hi, Venus. Hi, Venus.
Bring in our hold at T-minus 4 minutes. And we expect to hear some words here shortly on discussion on the launch vehicle issue.
Has confirmed that with a false positive indication. We are fully confident in the radar valve has installed. We recommend proceeding.
LC copies and concurs. LD? LD concurs. And NLM? NLM concurs. Roger. Continue to discuss a possible new T0 time, which currently is set up for 6:22 p.m. Eastern time.
6:22 p.m. They have resolved the issue.
Their teams to ensure that they're ready to pick up the count, and we'll stand by for more information.
Awesome!
Roger, understand spacecraft been given directions to go to internal power. The GOES-R program has been given a go to put the spacecraft on internal power, and now is 6:32 p.m. Eastern time.
6:32 p.m. The latest that we can launch it is 6:42 p.m. That's cutting really close. That's cutting really close, guys. I feel like sitting here and just like listening to this and the anxiety building, the excitement building. It's
Update the countdown clock for new T0 of 23:42 Zulu.
okay.
Roger, 23:42. And work.
So right now they're confirming the times.
And as you've heard, managers have determined
Atlas
that
Launch
they will
Control.
target the end of today's launch window with a projected T0 of 6:42 p.m. to enable the U.S. Air Force Eastern Range time to work through the issue that it has been working. Electrical systems, airborne. Go. Ground. Go. Facility. Go. RFSCS. Go. Flight control. Go. Go. Timer.
This is so cool.
Go. TCQ. Go. Umbilicals. Go. ECS. Go. Redline monitor. Go. Quality.
That's so
Go.
cool.
Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief.
ACs go.
Range coordinator. Clear to proceed.
Launch director. Launch director is go, and you have permission to launch. Timer, plan for 23:42. The counter starts at 23:38. Roger.
Oh my god.
T0 set for 23:42.
I'm like nervous.
Start at 23:38.
I'm so nervous right now. I'm so nervous right now. I'm so excited. This is gonna be so amazing.
Rolling is complete, and we have a go for launch at 6:42 p.m. Eastern Time. The count will resume in about a minute 35 seconds.
Oh my gosh.
And once resumed, from T-minus 4 minutes until launch, you'll be listening to launch conductor Doug Lebo and his team performing the final steps in the countdown procedure. 2 minutes, 50 seconds.
I hope I don't drop my phone when it happens.
40 seconds. Stabilize step 3.
Oh my god.
T-minus 30 seconds and counting.
Oh my gosh.
28. ECS reduce launch. Roger. 25. Status check. Go island. Go Centaur. Go R. 15 seconds and counting.
Oh my gosh. 15
T-minus
seconds.
10,
10.
9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff.
Oh my god.
That is sick. Elevating environmental intelligence to new heights and saving lives.
It's like blending in with the stars.